again. Here's question 34 from the 2014 exam. This is in the differentiation section. So we have a square pyramid can be constructed from a piece of paper by cutting identical triangles from each corner and folding up the edges. Okay, so we get this. This is what it is when it's flat, and then you cut out those triangle pieces, you fold it up to make your square-based pyramid. Okay, what are we going to have to do? Sheet of paper, the diagonal of which is 30. Okay, and the base of the pyramid is x by x. Okay, use Pythagoras Theorem to show that the vertical height is given by that. So we need to mark in some things on our picture so we can see very clearly where the vertical height is. So I just put in some x's. So I've got x is the length of the base of that. So that over here, that's also this bit here, is x or x or x. Just putting it everywhere. Right. Now we need the vertical height of the pyramid. Here's the pyramid. If I come straight down from the top of the pyramid to some point right, oh god, that should be straight, right in the middle. That's it, straight to the bottom. Now if I take a line from, I'm at the bottom now, coming to the edge, there, that'll be in the middle of the edge. And if I put in also the slant height, don't know that I'm going to need that, but anyway, here's the slant height if I was coming down. God, I'm sorry, I'm not very good at drawing straight lines on this tablet I'm using. And this line that goes from the top to the bottom, that is a right angle just there. Okay, let's see if we can go back here and work out some things. On my little picture here, the vertical height is that line there. And that's what, in this equation here, the vertical height is the h. So that's on mine what I'm going to call the h. Now I need to know the other measurements. The length from where it hits the bottom to the edge, well, if it's x all the way, that'll be x over 2. So that little bit in there, that will be x over 2. I think that's reasonably straightforward. Now, we've got the slant height of this, and that is the length of the pyramid. So on my picture here, that's sort of the triangle, that's the length from there to there, or from there to there, whichever way you want to go. That is the same as the slant height there. And then I can use Pythagoras Theorem on this triangle because it is a right angle triangle that I've drawn. So we just have to work out what this length is. We are told that if I continue this line and join it all up, that it's 30 all the way. We're told that here. So it's 30 from one end to the other. That means to halfway it's 15. And we know that this bit in here is x over 2. So that means this bit in here is 15 minus x over 2. That is from there to the top. And that is the slant height part of it all. So that bit is 15 minus x over 2. So all that came about just by drawing this triangle and then working back to how I had to start with, just remembering that the reason I got my 15s was because it was 30 all the way, because I'm told that in the question. So halfway, that is from my middle point, will be 15, half of that, and then you take away the bit, the x over 2 that you do know, or the half x that you do know. So then, what Pythagoras would have to say about that lot is that the square of the two shorter sides added together is equal to the square of the longer sides. So let's just write that down. We have the square of the short side, so we've got h squared, plus the square of the other short side, that's x over 2 squared, equals the square of the longer side. And we've got our equation set up now. It's now going to be a bit of an algebraic manipulation to end up getting it to look like we're required to get it to look like. So the first thing, I do want to get h by itself, so I'll take the x over 2 away, so I'm going to end up with h squared equals, therefore h squared equals 15 minus x over 2 squared minus x over 2 squared. Then h will then be the square root of that lot, but it doesn't yet look like I'm required to make it look, so I'm going to do some other stuff before I take my square root. Okay, I've got to get a 30 on the inside. At the moment I've got 15 minus x over 2. I'm going to put everything in this bracket over 2. At the moment the x already is over 2, but the 15 is over 1, so I'm going to multiply that by 2 over 2. 15 2's are 30, and now it's over 2, and I'm beginning to look a little bit more like I'm trying to get. On this other side, well, I can, that's just still x over 2 squared. Nearly there, really. I'm just going to do a little bit with those brackets. H squared equals. Going to separate out the top and the bottom parts. So I've got 30 minus x squared. Let me just make that look a little bit neater. Squared over 2 squared minus x squared over 2 squared. And now I will just combine those two. H squared then is all over 2 squared, 30 minus x squared, oops, 30 minus x squared minus x squared. Now I will take the square root of both sides, so h equals square root of that lot. And then I can take the square root of 2 squared will of course be 2, so I can take that outside of the square root sign, so h equals square root, this is just the top part now, all over 2. I've used a square root sign on the 2 squared. And notice when I took the square root, I've only taken the positive square root. The reason for that is this is a real situation, and we need to have a positive length for the height. It wouldn't make sense to have a negative length for the height. So in this situation you don't take the plus and minus the square root, you only take the positive, and this symbol is a positive symbol, so you don't need to write in plus here, because this symbol implies that it is positive anyway. So there we go, you can just leave it looking like that. And that, I believe, is exactly the same as I've got it up there. Let's just have a look. Yep. Okay, so that's what you had to do. When you do this yourself, I've probably put a few more lines of working in here than is absolutely necessary, but I do it just to hopefully explain reasonably clearly what it is I'm doing. Okay, I'll stop there.